The reason why we've come all the way around the world to look at these fossils is that they represent the first example of large organisms in the fossil record. We know that life existed before the Ediacaran fossils, and we certainly know that it existed afterwards. But they represent a crucial change in the history of life on Earth. For the first time, you can pick up a rock and see an organism in it with your eyes. You don't need a microscope anymore. And while that may not seem like a big deal, large organisms interact with their environment in completely different ways than microscopic organisms. So we believe that the Ediacaran fauna represents a fundamental change in marine ecosystems. And ecosystems basically just means the community of organisms that live in a place, how they interact with each other and how they interact with their environment. So the interesting thing about the Ediacaran time period is it's the first time that we see evidence of animals and complex algae. Before the Ediacaran, we had no evidence of these things existing. And in the Ediacaran, we start seeing evidence. And then right after the Ediacaran is something called the Cambrian time period. And the transition between the Ediacaran time period and the Cambrian time period is often called the Cambrian explosion, because across that boundary of time, we see a huge proliferation of animal and plant life in the world's oceans. So the Ediacaran time period can be thought of as the prelude, the lead up to the Cambrian explosion. And because of this, it's a very, very interesting time period for scientists of all types to study. So paleontologists, geologists, geochemists, paleoceanographers, evolutionary biologists, all of these different types of scientists love to study what happens in the Ediacaran and in the Cambrian explosion, because during this time interval, the scene is set for the rest of Earth history and the rest of life's diversity on Earth.